In this lecture, I'll introduce the idea of variables, units, and prefixes. A variable is a quantity that can change its value, and a unit is a definite magnitude or quantity that is used to measure the same type of quantity. Our normal way of writing numbers in physics is to say that a variable is equal to a number times a unit. So we could say the weight of an object is 35 pounds, that means 35 times 1 pound. Time is equal to 20 seconds, distance is equal to 5 miles. So the unit is always written to the right of the number. Units are there to give meaning to the numbers that we use in equations, and without units, we wouldn't have any way of understanding what our numbers meant. As an example, I could say I ran for 5, but that doesn't really tell you anything, because that could mean I ran for 5 seconds, or 5 minutes, or 5 hours, or maybe for 5 miles. So you don't even know if that's a unit of time or a unit of distance. Putting a unit next to the number gives the number meaning that it wouldn't have if it didn't have a unit. So the units tell us what these numbers are measuring. Units written next to numbers mean the unit is being multiplied by the number. In equations, units behave exactly like numbers being multiplied by the value they're written next to. So as an example, if I multiply 10 kilograms times 5 meters, I get 50 kilogram meters. And that can only really be true if we consider the units to be multiplied by the numbers they're next to. So you can see on the right they behave just like numbers being multiplied, where if I have 10 times 3 times 5 times 2, that's equal to 50 times 3 times 2. So if you replace the units with regular numbers, the same operation works. And if you divide two numbers with units, the units themselves get divided, just like they would if they were just regular numbers being multiplied by their number. If you raise numbers with units to a power, the unit also gets raised to that same power. So 10 meters cubed is equal to 10 cubed meters cubed. And in this way, units also behave the same as numbers being multiplied, because 10 times 4 cubed is equal to 10 cubed times 4 cubed. We can only add or subtract numbers that have the same unit. So 10 kilograms plus 5 kilograms is equal to 15 kilograms, and that makes sense. But 10 kilograms plus 5 meters is not equal to 15 kilogram meters. There's actually no answer to that problem. And in the same way, we can only add or subtract numbers that are multiplied by the same number. So if I add 10 times 3 plus 5 times 3, I know that that's equal to 15 times 3. But if I wanted to calculate 10 times 3 plus 5 times 2, that would not be equal to 15 times 3 times 2. It would equal a different value. So you can only add or subtract numbers that have the same unit. In IB physics specifically, we do not write units in numerators and denominators of fractions. Instead, we write them as having positive or negative powers. And just remember, what a negative power physically means is just 1 over that positive power. So 1 over x to the power of a is equal to x to the power of negative a. I have this example problem here where I'm multiplying and dividing these numbers, and I'm going to show you the correct way that we would write the result and the unit in IB physics specifically. So when I combine the numbers together and combine the units together, this is what I get. So I'm dividing 160 over 10, and I'm dividing those units in the numerator by the denominator. So I'm going to rewrite the units as having powers instead of being in a numerator or denominator, so that m in the denominator is canceled out by the m cubed in the numerator, and I'm just left with m squared. And a squared is still in the denominator, so I rewrite that as a to the power of negative 2. That just means that it's in the denominator squared. So that way of writing a unit on the bottom right is the way that we would record that unit in IB, rather than recording it as a fraction. This makes it easier to do math with units in more complicated problems. In physics, we are only going to use SI units. SI stands for Système International, which is French for the International System. SI units are the internationally agreed upon system of units, which all scientists in the world use. SI units are the modern form of the metric system, and they were designed specifically to be easy to use in science. So just to compare what you might normally use in the United States to an SI unit, in the imperial system, which most people in the United States use, we measure length in feet, whereas in SI units, we measure it in meters. We measure force in pounds. SI units were very specifically designed to be very, very easy to use in calculations. In an SI unit, 1 kilometer is equal to 1,000 meters, so that's a very easy to understand number, whereas in imperial units, 1 mile is equal to 5,280 feet, which is much more difficult to remember and do calculations with. So SI units were very specifically designed to be easy to use in science. There are only 7 fundamental SI units. You can see that I have them listed on the right: the meter, the kilogram, the second, the Kelvin, the mole, the ampere, and the candela. These are units that we can combine with each other to make all other units of measurement. So all units that we will use this year in physics are actually just combinations of these 7 basic units. Units that are not fundamental are called derived units. I'll give you a quick example of what a derived unit looks like. In physics, we measure force in units of capital N, which stands for a Newton. But this unit is actually made up of the fundamental units, because force is equal to mass times acceleration, and if you don't know that, that's fine. I'm just giving you an example, so I'm just going to have you follow along what I'm saying. And acceleration is equal to a change in velocity over time, and velocity is equal to a length traveled over time. So because velocity is length, which is measured in meters, over time, which is measured in seconds, the unit of velocity is a meter per second, or a meter times second to the power of -1. And because acceleration is velocity over time, that means the unit of acceleration is the unit of velocity over the unit of time, which is equal to a meter per second squared. And so the unit of force is equal to the unit of mass times the unit of acceleration, and the unit of mass, as I can see on my table, is a kilogram. So the unit of force is a kilogram meter per second squared, and I know that it's also equal to a Newton. So a Newton is actually just a stand-in for a kilogram meter per second squared, so it's a derived unit. It's a unit that's actually made up of the fundamental units. So that's what I mean by a fundamental versus a derived unit. SI units can have prefixes, which are symbols at the beginning of the unit, which change the size of the unit. I have the main prefixes that we use listed on the left. Giga means 10 to the power of 9, mega means 10 to the power of 6, kilo means 10 to the power of third, and you can read the rest. If I put one of these prefixes or one of these letters at the front of a unit, that multiplies the value of the unit by the value that I've listed in the table. As an example, a kilometer is equal to 10 to the third meters. So kilo is kind of taking the place of 10 to the third there. It means the same thing. So a kilometer is 10 to the third meters, or km is equal to 10 to the third m. A megameter would be 10 to the sixth meters, and a gigameter would be 10 to the ninth meters. And we can also go in the opposite direction, where a centimeter is 10 to the power of -2 meters, and a millimeter is 10 to the power of -3 meters, a micrometer is 10 to the power of -6 meters, and a nanometer is 10 to the power of -9 meters. So those prefixes take the place of those numbers and tell us how big or small the unit is. Notice that the kilogram is the only fundamental unit with a prefix. Scientists chose the kilogram as the fundamental unit for mass instead of the gram because a kilogram is closer in magnitude to everyday objects. It's about 2.2 pounds. So that's all the basic information that you need to know about variables, units, and prefixes. We're going to return to these concepts a lot throughout the year, and at the end of the course, we'll be able to reduce all of the units that were given to the 7 fundamental SI units.